temperature?
Hey, I don't know.
All right.
Do you birds sweat?
Hey, we don't have
I
time.
don't think they sweat.
The conversation is done.
That's just a big jump.
Okay, I talked about this yesterday. We kind of talked about it in the homework today, so I'm going to kind of not spend a ton of time on this. This is what I gave you yesterday, the idea that like things dissolve like things, and that just means that a polar object will dissolve polar things. Your number one polar solvent is going to be H2O. Here are some common things that are nonpolar. You're starting to figure out: oil, nonpolar, hydrocarbons. Have I explained what a hydrocarbon is?
Anything with hydrogen and carbon.
If it just has hydrogen and carbon, not
Yeah.
because you can have carbon and hydrogen with like an oxygen or something, and it's not a hydrocarbon. Does that make sense? Okay, bourbon. Okay. So you're probably familiar with soluble and insoluble. Those are a little bit simpler vocab words than ionization, dissociation, hydration, solvation, and all that shit. Okay. When a solute is able to dissolve, we say that that solute is soluble. That's familiar for you guys, right? Yeah, everyone?
Yeah.
Okay. Now, solubility is really a measurable quantity that tells us how much of a solute can dissolve in a solvent, or the maximum amount of solute that can dissolve in a...
We're doing that?
What?
We're going to do
Not today, but we will. Yep. Tomorrow, I'm pretty sure we will. Sooner we get done with this time. Okay. If solvation cannot occur, dissolving cannot occur, then we say that the solute is not soluble. Equilibrium, huh? This is kind of thrown in there more so to get you guys thinking about the idea of equilibrium, because the dreaded 15th chapter is all about equilibrium.
Oh, I love the equilibrium.
Okay. Equilibrium means really just equal. So you have static equilibrium and dynamic equilibrium. Static is usually just referring to balanced forces. Dynamic equilibrium is a balance of two processes. This is more what you see in chemistry. In chemistry, dynamic really means movement too. So this is really the equal and opposite processes. So I think in physical science they gave you an example of someone in a boat and water's flowing into the boat, and they're getting rid of the water as fast as the water's coming in. They're not making any progress. You're not seeing any net change, but is stuff still happening? Yes. Is there still movement?
Yeah.
Yes. Okay? This is very much a concept that's important in chemistry, because believe it or not, we reach equilibrium for chemical reactions, and even though we don't see a reaction occurring, we actually have the forward reaction and the reverse reaction happening at the same rate. So even though we don't see much going on, at a subatomic level, there's frantic movement. And this is probably what will make you go a little bit crazy, because you can't see it. But knowing that chemistry equilibrium is usually dynamic, in that it's a moving process, should help you understand. First, I got to review what precipitate is. I know Maddie said it the other day.
The solid that settles at the bottom of the solution.
Yes, I don't like the word settles, because that makes it sound like it never dissolved in the first place. Does that make sense? Separates out of solution and then settles at the bottom. Sure. Okay? So a precipitate was something that was once dissolved and then crashed out of solution, or undissolved and settled at the bottom. Okay? And it says, when your solution is at equilibrium, there are two processes that are occurring. The process of dissolving and the process of precipitating, which is just undissolving. Does that make sense? Okay? So when you take and you dissolve something and you get it to its saturation point, or you make it so that it cannot dissolve anymore, okay, do you see things moving back and forth between being dissolved and being undissolved? Do you see it? Believe it or not, it's happening even though you can't see it. So when you reach your saturation point, what you're reaching is a point where the rate at which something dissolves is equal to the rate at which something undissolves, so you don't see a net change. Solution equilibrium. Okay, this point is called the saturated point. You've probably heard that word quite a bit, even in biology, I'm assuming. Maybe there's a different context. You might be talking about saturated fats and things like that. But if you're saturated, that just means you cannot dissolve anymore, or, well, I shouldn't say that. You're at your maximum amount dissolved under the conditions that you're in. Okay? It's been a while since I've taken biology. Do you talk about saturated and unsaturated fats?
That or in health.
Do you remember what the difference was?
Yeah, unsaturated. One of them dissolves.
One of them, I think, dissolves in fat, and one of them doesn't.
Yeah, saturated dissolves.
Yeah. So here's what, in chemistry, what saturated and unsaturated and then supersaturated means. If I have less than the total or maximum amount that I can dissolve in solution, then I'm unsaturated. What that simply means is I could dissolve more if I wanted to. Does that make sense?
So saturated means it's already at the limit.
Yeah, it's at the limit. However, there is such a thing as supersaturated, but you can only do that under certain conditions. At a specific temperature, there's only so much solute that you can add. However, you can raise the temperature. I think there's a homework question on this. How do you create a supersaturated solution? Here's how you do it. You raise the temperature, which allows you to dissolve more.
Hey.
And then you let it cool back down to a lower temperature, and it will be organized in a way that it will stay dissolved unless you trip it. And what I mean by trip it is cause it to usually just jostle the container, and you'll actually see a lot of just crash out of solution all at once. Yes?
There was a question on our test that said you can create a slight vacuum by having.
I saw that.
Oh, today?
Yeah.
Which
How-
one
what was the answer?
Was it heat?
Wait, why do you have the same question?
Yeah,
I don't know.
It was heat, then plug, then cool.
Yeah,
sure
yeah,
that's
that's
what-
right.
Because
Yeah, that's
heat, the
Heat,
water,
cool.
the vapor will fill up the can,
Yeah.
and then you put the cap on it, and there's little air but a lot of vapor, and then when you cool it, the vapor will go down into the liquid.
That's what I put
Yep,
too.
that makes sense.
Nice.
We did the same question last year too. Yeah.
That's not true. There was a whole section on phase diagrams.
That's true.
That's just
that's
four questions.
Yeah.
But it's
And then
just,
there was that question.
they explained triple point for us though.
Yeah. They
I
were
always
like,
say what it
this
is, that
a
what's triple point.
Yeah.
I'm like,
Yeah.
booyah.
And there was
Dude,
one
but
that
the
was,
so
And there was one. How many elements are in this?
Wow. How is the
That's what's
ACT
so
was that
frustrating
easy as
about
that?
standardized tests is they either get you something that's so bizarre and out of this world, or they give you something that's so obvious.
yeah, there's nothing
It's like there's no.
comparable. It's
The
so-
questions that confuse me most is about the sun and then solar wind or
That was
something. I'm like,
so
what in the
stupid.
Well,
world?
and that's what's dumb. It's
Because
like
we learned how to do science, not just random science facts.
Yeah, exactly.
Why do I have to worry about solar wind?
anyways. And what's funny is if you looked at that test. I know. When you looked at that test, you saw like every possible science subject packed into your sophomore or junior level. Like, shouldn't they focus on what you're currently learning at that
Yes.
stage?
So I feel like that'd
Exactly.
be
The
different
problem is
between
though-
private.
Tomorrow is our last day
Yeah.
of
A
our.
little
A lot
bit,
of-
but literally there was like 15 different topics of, you know, you had a physical science topic, I saw a question that I teach in physics, the bending of light.
No.
Oh, yeah.
Yeah, I didn't know that
Which
one.
one was that?
Tomorrow?
I tried to
Lower density to higher density?
If it bends toward the normal, it's going to be a higher density, lower to higher.
Yes, yes, that's what I did.
Yeah.
You want to say?
Marty's like,
I don't remember. I think
You don't
that.
know?
saw a slow one.
Yeah.
I think that might have.
and it
So,
might
yeah,
have been
I mean,
slightly
So I was like, I've taught some in this chemistry, some in physical science, some in physics. A lot of this there was a lot of biology, there was like a ton of ecosystem stuff, I felt like.
Yeah.
All of the
And then there was like,
it's biased against us.
and then there was like,
Social studies was a struggle.
Dude,
That was
I
so
felt
true.
so
Dude.
stupid. You guys don't.
Jake's like, I don't even know what the sample was.
Dude,
Yeah, just like
I know what it was. I didn't know the sample.
All right, is that
as well.
Yeah, true.
Yeah,
Like,
very true, Gage.
What? Like I know 50
We'll finish
maybe.
this lesson tomorrow.
From,
Yeah, no homework.
No homework, but
Morning.
listen.
Right at my house.
Church.
Hey, we cannot waste time. I kind of knew we were at the point where we weren't gonna get through everything, so I was okay having a little 3-minute conversation at the end of class. But we need to stay on task, and I know I got on Trinity for getting up, and I kind of made her my I made her my scapegoat. But that's the type of stuff, those little things, those side topics, those little rabbit trails that waste so much time.
It's true.
So.
Can you go back to the camera and look at how many rabbit trails?
And I know that I'm not always the greatest at stopping rabbit trails, but